Hello, teachers. Welcome to Jefferson Lab's annual Teacher Night. We are so glad to have you join us this evening. My name is Carol McKisson. I work in the Science Education Department at Jefferson Lab. I am the high school program coordinator and lead for fifth grade Jefferson Lab Science Activities for Teachers, also known as JSAT. To kick off our program, it is my pleasure to introduce the director of Jefferson Lab, Dr. Stuart Henderson. Stuart has served as the director of Jefferson Lab, Virginia's world-leading nuclear physics research laboratory, and part of the U.S. National Lab System since April 3rd, 2017. Spurred by a strong interest in understanding how things work, which involved taking apart a few things like a couple of old cars, his dad's lawnmower, and some stereo equipment, he turned that interest into a passion and ultimately a career. Dr. Henderson is an internationally recognized expert in particle accelerators. He served in various leadership positions at other national labs prior to coming to Jefferson Lab. Dr. Henderson earned his bachelor's degree in chemistry from Vanderbilt University and a PhD in physics from Yale University. Welcome to Teacher Night, Stuart.
Thanks so much, Carol. Really appreciate this opportunity to welcome all of you. So welcome to Jefferson Lab, virtually, of course, but great to see you here, and wonderful to see so many online joining us tonight for this Teacher's Night. This is always a very exciting event for us at the lab. Teachers are critical to everything we're all about. We do science, and to be able to do the science that we do, we need smart scientists and engineers and technicians, and the role that you all play in educating these wonderful students is something that we really appreciate and really count on, and it's one reason we put so much effort into events like this and our involvement with the local school system. So let me say a few words about the laboratory. Many of you, I'm sure, know a lot about Jefferson Lab, but maybe not everyone. So as Carol said, we are one of the 17 U.S. Department of Energy national laboratories. We're one of 10 labs that focus on basic fundamental science. And in our case, the basic fundamental science that we focus on is the atomic nucleus, the science of the atomic nucleus, what the atomic nucleus is made of, and in particular at the level of the protons and neutrons that make up all atomic nuclei, what those protons and neutrons are made up of. So it turns out they are made up of subatomic particles called quarks that are held together by other particles called gluons, and the force between those quarks is the strongest known force in the universe. And those quarks make up all the protons, neutrons, and atomic nuclei of all the visible matter in the universe. And we are extremely privileged to be able to spend day out and day out studying protons, neutrons, and their quarks that make them up. So we are the leading laboratory in the world for this type of science. We operate the world's leading electron microscope to peer inside protons and neutrons and try to better understand what's going on. And that electron microscope is a large particle accelerator. And you can sort of see at the top of what's shown on the screen, the outline of that racetrack-shaped particle accelerator. So it takes enormous teams of scientists, engineers, and technicians to be able to carry out this research, and the researchers come from all over the world. We have nearly 2,000 researchers who come from 35 countries around the planet, from about 35 states here in the United States, and from about 250 universities and other laboratories worldwide. So it's quite an operation, and it's something that we are, of course, very excited and privileged to be able to do day in and day out. So with that brief introduction, I really want to just take a moment to acknowledge all the hard work that you all have done and how appreciative we are of the hard work, particularly over the last couple of years of the pandemic. I can only imagine the challenges that you've had to confront, and it's really inspiring to all of us. And as I said, you know, the role that you play in our lives, indirect as it may seem, is really critically important. So with that, again, welcome to this virtual Teachers Night, and have fun. Thank you.
Thank you, Stuart. The education group always appreciates your support and the support of your leadership team. Tonight, we would like to learn more about you, our participants, and your teaching experiences. There are multiple ways to interact with us tonight. There's the chat function that we encourage you to utilize for reflections and comments. We have the Q&A feature where you can post any questions that you have for the presenters. Finally, we also have polls that will be posted so we can learn a little bit more about you. Let's post our first poll. Our first question is, what grade level do you teach? We hope that everyone will find something to use with their students. Joining us behind the scenes tonight are my outstanding science education teammates. Lisa Searles Law, our team lead, the undergraduate program coordinator, and JSAT 8th grade lead. Steve Gagnon, our webmaster extraordinaire and co-star of Frostbite Theater. Rhonda Bell, our outreach program coordinator and lead for JSAT 6th grade. And last but certainly not least, Jalen Dio, our undergraduate intern, who we rely on for just about everything. Again, please enjoy using the chat feature for chatting, but if you have a specific question, please put it in the Q&A at any time. Are you guys ready for another poll? Our next question is, have you participated in JSAT in the past? For those of you who have never participated in JSAT, we hope you will consider participating in the future. Teacher Night was developed as part of the JSAT program, Jefferson Lab Science Activities for Teachers. The JSAT program is intended for 5th, 6th, and 8th grade physical science teachers interested in a hands-on approach to teaching science. This program is free and generously supported by the Jefferson Lab Science Associates Initiative Fund. Each teacher who participates in the program receives over $700 in materials to support hands-on instruction. Each JSAT cohort may have up to 20 participants and meets twice a month during the school year. We are planning on hosting the JSAT program in person next fall with the flexibility of transitioning to virtual if needed. We owe a big shout out to the instructors of the JSAT program. It truly would not be possible without them. The JSAT instructors for 5th grade are Jennifer Grimm and Caitlin Leitner. The 6th grade instructors are Aaron Watson and Aaron Little. And the instructors for JSAT 8th grade are Tanya Bates and Missy Brahacek. They are truly master teachers, and we thank them so much for the work that they do to help make the JSAT program successful. The structure for tonight's program includes pre-recorded demonstrations presented by our very own JSAT teachers who are currently available in the Q&A to answer questions you may have. All of the activities presented tonight are available for download on our website, in addition to more than 40 science activities provided by our JSAT teachers. This year, we have decided to add a searchable spreadsheet of all the activities and their standards of learning objectives to assist with identifying and locating the activities that meet your curriculum. This spreadsheet will be included in the folder that you can download from our science education website. Finally, we have lots of free door prizes that you are eligible to win. Later in tonight's event, we will give you instructions on registering for the door prizes. Remember, if you have questions, the presenting teachers are available in the Q&A to respond. Feel free to post questions anytime during the demonstrations. If we are unable to answer all of your questions tonight, they will be posted with the answers on our website. Our first demonstration this evening is from William Hawthorne, who teaches 8th grade. William's Bottle Flip Challenge is an SOL-based scientific investigation activity. The activity can be modified to be appropriate for all grade levels as scientific investigation criteria becomes more advanced as the grade levels increase.
Hey, welcome to the SBS Bottle Flip STEM Challenge today. I'm Mr. H from the School of Blessed Sacrament here in New York City. Today we will be testing out water levels in different types of bottles, see if we can land them straight up. Some of the instructions for today's challenge are don't flip out, it's only physics. We're doing some complex physics behind the activity today. Is mass, fluid dynamics, projectile motion, angular momentum, centrifugal force, and gravity. The challenge is that the students will be walking around, flipping each bottle 25 times, and we're going to see which of the bottle levels of water will be flipped better than the others. We'll be taking some data. Here's the data tracker. We'll be doing some examples of the frequency of them. We'll graph them, and then we'll write a conclusion. Which water bottle has the highest success rates? Which do we think is best? Why do certain water bottles flip better than others? And so we've set up 10 different water bottles. The first water bottle is 2 centimeters. Second bottle is 4 centimeters. Third bottle is 6 centimeters. The fourth bottle is 8 centimeters. The fifth bottle is 10 centimeters. The sixth bottle is 12 centimeters. The seventh bottle is 14 centimeters. And the eighth bottle is 16 centimeters. And last but not least, we're going to try to land the bottle on its head as an extra credit bonus. So we concluded that 6 centimeters or 8 centimeters in the water bottle, due to the level of the water, seems to be the most successful. Now we're going to try the extra credit, where somebody's going to try to attempt to land the bottle on its head.
Mr. H is going to attempt to cap the bottle.
Thank you, William. We always flip out when teachers make science flippin' fun.
Oh.
Please post any questions you have for William in the Q&A.
Thank you so much, man. I'm thrilled to just do an activity in the front of the room and then have kids understand, I'll do an activity or some type of demonstration and then not say anything. And I like kids to try to understand what just happened and then try to dig into the science of what is happening inside. Why is the bottle standing up? Why is something happening like that? I feel like kids get engaged and excited about understanding real science, real world learning, and I want them to love learning and love science. And so we engage in these crazy demonstrations and then figure out the science behind it. And it seems to work with my class that I started with the 8th grade and I already was invited all the way down to 4th grade to have the 4th graders. As I was telling the JLab people, my principal is now upset with me because everybody's carrying around a water bottle, flipping it all over the place. So we've had to constrain the kids on flipping bottles, but there is definite science about them understanding the physics behind it. And so I can always talk to them about that. I love the activity. I love the idea of kids wanting to engage in anything that has to do with science.
So we do have a question, a little off the cuff here, but did it really just take you 3 flips to cap the bottle?
That time it did, yes. But as I said, I've been flipping bottles in 8th grade, 7th grade, 6th grade, 5th grade, 4th grade, and yes, I bet the kids on whether I can flip it within 5 times for homework or not. So I do practice myself.
And one of the viewers is wondering how you brought it down to 4th grade.
4th grade is that I used bigger bottles, and then I used smaller bottles, real small bottles, and we found out we used 64-ounce bottles, and they landed better, so there was a bigger base on them, and so we in the 8th grade students figured out that 6 centimeters in a bottle, which is almost about a third of the water in the size of the bottle, is the best when it flips. So I kind of set it up like that. I did with 4th graders, I was more lenient on pre-setting up the experiment, where with 8th graders, I let them figure it out themselves. I let them measure the water, I let them pour the water in the bottles, but 4th grade, I preset everything up.
And at the moment, there are no more open questions, but if you think of some, feel free to put them in the Q&A. And William, if you wouldn't mind monitoring the Q&A and any additional questions that come to you, if you wouldn't mind answering them there.
Sure, no problem. Thank you so much. I really appreciate it.
Thank you. And back to you, Carol.
All right. Thank you, Steve. Our second demonstration tonight is given by Evelyn Jesse, who teaches 5th grade. Evelyn's edible plate tectonics activity falls under Earth and Space Systems and aligns with 2018 revised SOL 5.8 A and B.
Oh, hi there. I was just putting together a puzzle. Whenever I put together a puzzle, I think of Earth's crust because it's really like a puzzle with much larger pieces. So of course, the students are going to need some background knowledge for this activity. At this point, we have covered the layers of the Earth, and we always love creating representations of the layers of the Earth using Play-Doh. So they make a circular model, adding more and more colors of Play-Doh until they have the 4 different colors for the inner core, outer core, mantle, and crust. And then we cut it in half so they can see a cross section of a model of the layers of the Earth, and they make a little key for what each color represents. So the kids understand the layers of the Earth. They know that temperature and pressure increase as you go deeper toward the center of the Earth. They have learned about Pangea, and we have a great Pangea puzzle that we use. So they can see that there's fossil evidence on different continents that supports that. And they've learned about Alfred Wegener's theory of continental drift, that plates are gradually, constantly moving over time. So then it's time to really zoom in on the plates. And I always tell the kids, we're not focusing on the plates that you eat dinner on. These plates are much bigger. They are huge sections of the Earth's crust. So the Earth's crust is made up of about 20 continent-sized pieces called plates. The Earth's heat energy or thermal energy causes movement of material, magma, within the Earth. So we're talking about, specifically in this lesson, magma from the mantle. This movement causes the plates to constantly move and bump into each other. And again, this is a gradual process taking place over time. Here is a major tectonic plates map that I found, that I borrowed from Britannica Kids. And I liked it because it shows the direction of plate movement. So you can see that some are going toward each other, colliding, some are diverging, they're going away from each other, and some are sliding past each other. Those plates are constantly, gradually in motion. So there are 3 types of plate boundaries that I just alluded to. Plates can move together, convergent boundaries. Plates can move apart, divergent boundaries, and plates can slip past each other, sliding boundaries. And this is all, these slides are for the most part from the JLab teacher share PowerPoint that they give to teachers in the program. So I highly recommend JSAT 5 to all the 5th grade teachers out there. And now continuing on, when I teach this vocabulary to the students to help clarify the meanings of each of these vocabulary words, because they can be a bit overwhelming, I teach them that convergent plates collide, divergent plates divide, and transform plates slide. One of my coworkers found a great YouTube song that covers these plate boundaries, and the kids always love dancing and doing the motions, because even if they don't like to dance, they'll do the motions that convergent plates collide, divergent plates divide, and transform plates slide. So here are my safety tips. Wear safety goggles. So that is really optional. I have a kit of safety goggles, and the kids love to use those whenever they can. So that's more for fun than anything else. Of course, I guess they could get icing in their eye. Keep all materials on the surface. So we're dealing with edible materials, and we want to keep them on the surface to avoid a mess. It can get a little messy with the icing. Do not eat any materials needed for this demonstration. Now it's up to you when it's all done if you're going to let your students eat the materials or not. Always follow your school's health protocols. So do what's best for your class. And then kids are going to want to wash their hands after this activity because they are messing with that icing. So this lesson is edible plate tectonics. So you're going to need some edible things. You're going to need frosting and graham crackers. That makes the edible plate tectonics, and then some other things as well. So you'll need wax paper. I always give each kid their own piece on their desk to protect their desk from the frosting. You're going to need a plastic knife, but I actually don't use a plastic knife. I give the kids popsicle sticks. Works just as well, and to me seems a little bit safer. And then you're also going to need some water to wet the edges of, I got myself quite a bit here, more than necessary, to wet the edges of the graham crackers when you get to convergent plate boundaries. So once you have your materials, you are ready to go. And I'm going to flip back and forth to my document camera so you can see the handout that is linked in your folder for tonight. I just screenshotted from that, and then the activity as I walk through it. So you're going to start with spreading the frosting on wax paper to cover an area larger than a graham cracker. So I usually give them a big old spoonful of icing, and then they use their popsicle stick to spread it around. So let me switch over my document camera. This may even be a bit too much. There we go. So I am spreading that icing around to a surface area that's greater than a graham cracker, because the graham crackers are going to need to slide around on this. Let me zoom out just a tad there. And ask the kids as they're spreading this out what this could represent. So they've learned about the layers of the earth, and we know we're talking about plate tectonics of the earth's crust. So what could be under those plates? All right, I think it is successfully spread. So now I'm going to hop back over to the PowerPoint to continue walking you through that handout. So then you're going to break that 1 graham cracker. The kids are going to break that 1 graham cracker in half, so that they have those 2. Each one is representing 1 plate. So there's these 2 rectangles, and I'm going to put them touching on top of the icing. So let me switch over to the document camera for that. So here they are, they're touching on the icing. So at this point, I would ask the kids, thinking of the layers of the earth, and these are plates, what layer of the earth is represented by these plates? And they're going to say, oh, okay, we've learned about the plates of the earth's crust. So these are obviously not actually plates of the earth's crust. They're graham crackers, but they are representing 2 plates of the earth's crust. And we know that those plates are constantly in motion. So then ask them what the icing represents. What is kind of helping those plates to move around? And that's going to be the magma in the mantle. So let me switch back over to the PowerPoint. That would answer those first 2 questions on the handout. And then here's where the fun begins. We get to create those boundaries. So we're going to pull the plates apart, those graham crackers apart, to expose some frosting. And when those plates move apart, the kids are going to see that it creates cracks in the earth called a rift valley. Pulling those plates allows the hot melted rock to come up through the crack in the earth. And this is how a volcano's opening is formed. I also teach the kids that this is how the mid-ocean ridge is formed, because those plates are diverging, and then that hot melted rock is coming up and it's cooling, and we get the mid-ocean ridge. But let me switch back over to the document camera. All right, so here are those plates together, and they're diverging, they're dividing, and so this hot magma can come up there, and it's of course going to cool. All right, so divergent plates divide. Now I'm going to switch back over to that PowerPoint. We have successfully represented divergent plates dividing. It is called a divergent boundary. Then we're going to put those 2 plates back together, And we're going to slide the edges of the crackers, the graham crackers, past each other. So slide those plates. This type of boundary, of course, is called a transform boundary, and it can cause a fault, which is a crack in the crust, to be created. The San Andreas Fault in California is a type of this. So here we go. You can feel them catching on each other as you're sliding. You can't quite hear it, but I can hear it really well as they're sliding past each other. All right. So we can see that some of the graham cracker did, there we go, kind of crack off there as they were glitching. They were catching on each other, sliding past. And that is, in fact, a transform slide plate boundary. Now we get to the part where we need the water. So I'm going to wet the edges of the crackers that are facing each other. And I'm actually going to do this and then switch to the document camera. So I have wet the edges that are facing each other. And this is why you wash your hands when you're all done. I'm getting a little icing on those fingers. Okay, and I'm going to push down and pull them together. And so I kind of get, you can see there's this formation of something new. So let me switch back. So this is, of course, a convergent plate boundary, and you could see there was this formation of something new. When the plates collide, mountains are formed, such as the Appalachian Range in North America. I have a picture for you on this slide. But also, if you want to show the kids, subduction is when one plate is going to go under the other, and then you get something like an ocean trench. All right. So then there's this formative assessment on the handout that's in your folder. So they're going to circle a convergent plate boundary, divergent boundary, and transform boundary representation with arrows. Then they're going to explain how mountains are formed. So of course, there's convergent boundaries, and they're going to explain how faults are formed. And I highly recommend this activity because it is so hands-on. Even if you can't eat the materials, it's fun, it smells great. And there are different kinds of icing that you can buy as needed, different kinds of graham crackers that you can buy as needed. And you could even use other materials, laminated index cards, with the icing if you needed to. So do what's best for your class. But this is a really fun, engaging lesson activity that I got from JLab. And I highly, highly recommend JSAT 5 to anyone out there listening, because this is one of many, many ideas and materials that you receive through this incredible program. All right. Thanks for watching, everybody.
Thank you, Evelyn, for that magnificent demonstration. If anybody has any questions for Evelyn, please put them in the Q&A.
So we were wondering how long it takes to do this activity.
It depends on how prepared in advance you are. If you've broken the graham crackers and you have all the wax paper torn and ready to go, like we all try to do, preparing in advance, then it really doesn't take that long. But I will say I supplement it, and I looped up with my students last year from 4th grade to 5th grade, and the science is very different. So plate tectonics were not necessarily my strength, but I joined an incredible team. The majority of the teachers on the team have been through JSAT 5, and they had all of these ideas. So one of my coworkers actually made a video to share this virtually. She did it as a demo, and the kids could follow along if they had the materials at home during virtual learning. But we supplement it with things such as the plate boundary wrap by Mr. Comerfield on YouTube. I don't know if I can give him a shout out, but we do, this activity, and we'll do the convergent plates collide, divergent plates divide, transform plates slide along with his wrap. And that takes a little bit of time too. There are also some great images that you can find, some photographs that you can find online. I used Science for Inquiry this year to find photographs, and so that really brings to life the plate boundaries, because the graham crackers and icing are certainly engaging, and the kids have so much fun actually making models of those plate boundaries. But to see in real life the effects of the convergent, divergent, and transform plate boundaries is powerful and a real world connection for sure. So I would say it takes maybe half an hour. That said, it depends on the questions that the kids ask and what you supplement with.
And I don't see any further questions in the Q&A, but again, if you all think of some later on, feel free to put it in there, and Evelyn will be monitoring that throughout the night. And back to you, Carol.
Thank you, Steve. Let's do another poll. What are the most challenging materials to purchase for your classroom? Consumables or science equipment? Jalen Dio will now give us an overview of the door prize procedure.
Good evening, everyone. Tonight, you all have the opportunity to receive a variety of door prizes that can be used in your classroom. Hopefully, we can help with that challenge in getting materials. These prizes range from general classroom materials to scientific equipment and full activity kits with class sets of materials and handouts. A complete list of the door prizes available can be found at tinyurl.com/listtn2022. To get signed up for these door prizes, please complete the door registration form at tinyurl.com/registertn2022. You can also get to the form by using your mobile device and scanning the QR code, which will be on the next slide. You can also use the link, which is going to be posted in the chat. We will announce our door prize winners at the end of tonight's event, so be sure to stick around to see if you won. We will be shipping these materials directly to the address that you provide in the form, which can be either your school or your home. However, we are not allowed to ship to PO boxes, so please keep that in mind. For the next 6 minutes, we will be taking a break so that you can complete this registration form. Best of luck to everyone, and we will see you soon in 6.
Welcome back, everyone. For those of you not familiar with Jefferson Lab's website or need a refresher, Steve Gagnon will now share where you can find resources and activities presented tonight, including our JSAT application. Once again, feel free to put questions in the Q&A while Steve is talking. Take it away, Steve.
Thank you, Carol, and hello, teachers. If you are unaware, our website address is education.jlab.org. If you forget, or you can just go to Google and search for Jefferson Lab Education, and it'll show up. Either way, this is where you'll end up. The homepage is nice for finding frequently used items and time-sensitive items. You'll notice at the top of the right-hand column, there's a link for downloading the activities from today's event. Don't go there right now. It's not actually active right now. It'll be active at 7:05 this evening. And this isn't just for the 4 activities that are being highlighted tonight. All the teachers in the JSAT program have contributed activities for downloading, and you can get them from that link once it becomes active. But that link won't always be there. Eventually, it will go away. And if you come looking for it one day and it isn't there, how will you find it? Well, the easiest thing will be to click the teacher menu that's listed up at the top. If you click on that, you'll end up on a page where all of our teacher resources are listed. If you're interested in the JSAT program, you can click on that first link and fill in an application. The application is online this year, which is new for us, and that should be fun. So go ahead and give that a try. Now, there are a bunch of resources listed on this page. We have the table of elements. We have games based on the table of elements. We have the Who Wants to Win $1 Million game. The money is fake, so don't get too excited about it. We have activities from our Beams program. We have puzzles from this fall's virtual open house. We have videos. We have science at home videos, which are experiments we conduct, but the students take the data. These are things like reading the level of a graduated cylinder in a density lab. Basically, we have the equipment and the students get the readings through the videos. All the science at home videos also have lab sheets that you can download, so you can do those with your classes. And what's probably more relevant for you at this time of the year is our Virginia Standards of Learning practice site. This site contains all the science and all the math questions that the Virginia Department of Education has released over the years. And not only can you pick a grade level and a subject area, the questions can be filtered by strands. So if a student needs additional practice with Earth and space sciences, they can receive just those questions. So here is an example question. Hopefully, all of you know the answer. If you don't, a fair number of the questions have explanations written for them. So hopefully those are helpful. Once again, education.jlab.org is where we go. And thank you very much. And I don't see any questions for me, which is probably good for all involved. And again, if you have questions later on, feel free to put them in there and we'll get to them.
There is a question in the chat, Steve.
Oh, I did not see the chat. Could you find it for me?
From Mrs. McClellan, it says, for the practice test, how do you view your student scores? I looked at FAQ and could not figure it out.
So the students need their recovery code. And once they give you the recovery code on the front page of the SOL, there's the last button basically says something of the effect of view an old test. You click on that, you put in the recovery code, you fill in the CAPTCHA that makes it so that you're not a robot trying to do this, and then it'll pull it up. Keep in mind that due to space constraints, we can't keep every test indefinitely. And I forget what it is now, but it's something on the order of 3 weeks. So if a student gives you a thing and it's more than 3 weeks old, it won't be on our site anymore. But yes, you can do it that way. Okay, thank you, Carol. Back to Carol.
Thanks, Steve. And yes, if you have not visited our website, please do so. It's full of stuff for you, for teachers. All right. Our third demonstration this evening is from Christina Sellis, who teaches 6th grade. Christina's demonstration is on wetlands filtration. Her activity aligns with 2018 SOL Objective 6.8.
Hi, I am going to show you 2 labs you can do with the same material almost, and one would lead to the other, but if you have a time constraint, then you can choose one or the other. What you will need for the first lab are 4 2-liter bottles, and you would have to cut them about 1/3 of the way down. And I suggest these really nice sharp scissors. And once you cut them, they become like a funnel for the inside. So you would have 4 of those. You'd have coffee filter, soil, sand, and rocks. And the first lab would involve the students making a hypothesis about which of these materials would make the best filter for muddy water. And you will also need muddy water, and all you have to do for this muddy water is put water and soil, mix it up, and that's it. So the first wetlands you would create would just be with this coffee filter. So you put it inside the top, then you place the muddy water inside, and you'd observe to see how well it filters. And the students would make qualitative observations on their lab sheet. The next one would be the coffee filter and soil. And then you see how well that filters the muddy water. Then you would do the coffee filter and sand. And see how well that filters the muddy water. And last, you do the coffee filter and rocks. And you'd see how well that filters the muddy water. Be careful how you put it in because it is very easy to miss the coffee filter. So once all the water has been filtered, you may have a discussion on which material worked best as a filter, and they would finish their lab. The next lab would be that they use the same materials to create their own wetlands, but this time they can layer them, and they will have to choose how they would like to layer the materials to create the best filter. They have to plan it and draw it out first, and there's a space in the lab where there's the bottle, a drawing of a bottle, and they just have to draw what they're going to put and label it. Once they have their plan, they get to build it. And this time, they would build their little mini wetlands in tiny bottles, probably 16-ounce bottles. Again, please, you get to cut the bottles. And then they can use any of these materials. Once the whole class is finished, and once the whole class has built their wetlands, you give them water, the muddy water, and then they will observe how their mini wetlands did as far as filtering water. Once we're all done and everything, all the muddy water has been filtered, as a class, you decide who created the best wetland model. And you can give them a prize. What I did was take a picture and post it on our board. And then the last thing in the lab is you decide what you want to change, what you want to keep, if you want to layer differently, and there's that discussion too. And then the lesson is over. Thank you.
Thank you, Christina. I'm sure teachers can't wait to filter through this activity. If you have any questions for Christina, please put them in the Q&A.
So there was a question in the Q&A, but Christina answered it by typing. I wouldn't mind though she would go back and state it verbally. The question was, is there a recommended ratio of water to soil?
No, but I just eye it, and you can't have too much soil or else it's just too much soil, and you can't have too little soil because then what's the point? So I would say about 2 cups to whatever that was, the pitcher was, a gallon, maybe half a gallon. Just eye it. Also, to save time, another thing I did as we determined who won the best wetland model or filtration system is that I had them compare their wetland to somebody next to them. Now, whoever was better, they got to keep their bottle, and the one that wasn't, I took it. And then the people left chose to another one and another one, until finally there was only 2 left. And then because I have 2 science classes, then we compared the 2 science classes, the winner of the 1 and the 2, and we had our grand winner. And they were super embarrassed after I took their picture.
Can you share which method filtered the best?
Me?
Yes.
Oof.
I think they want the results of the experiment without doing the experiment.
Oh, geez. I did this like months ago. I can't remember what I did yesterday. I cannot remember. I know I took it. It was like a combination of the JSAT that Aaron's taught me, and then JRA. We did that experiment with JRA, and that's the James River Association. And I think definitely not sand first, because that will filter right through. So I think it was rock, soil, sand, something like that. Definitely rock first would probably be one of the best. But then they do different things though.
And when you layer your wetland, do you layer it in the filter?
I didn't understand the question.
When you layer your wetland, do you layer it in the filter? And that's all I can give you.
Well, they have to draw it. So on the experiment sheet, there's like a drawing of a bottle, exactly how they would see it. And they have to draw what they want to do. And then they have to layer it exactly on their little mini wetland bottle. So if they put rock, sand, soil on their mini wetland, they're going to put rock, sand, soil.
And I don't see any other questions. So again, like the other times, if you have questions after the fact, feel free to put them in the Q&A and we will get to them. And back to you, Carol.
Thanks, Steve. Good questions. And last but not least is a demonstration by 6th grade teacher Alexis Tharp. Alexis will demonstrate air pressure, which aligns with SOL 6.7B and C.
my YouTube channel. Just kidding. That was terrible. Okay. I just want to let you know that I recorded your air pressure at home activities. I wanted to give you a chance to try them on your own first before I posted them for you. So take a look. Tell me what you think. Iris, come say hello. You say hi to everyone. She didn't help. Okay. Hope you guys enjoy them. Bye.
Thank you so much, Alexis. Iris sure knows her science and likely pressures you for attention. Please post any questions you have for Alexis in the Q&A.
So we don't have any posted questions, but we have a lot of happy comments in the chat. Just wondering though, are there any tricks, any way to screw any of these things up? Is there anything that's particularly difficult to do?
No, well, that one was kind of designed for students to be able to do at home with parent supervision. But I do it as stations within the classroom. The crush can is a demonstration, but everything else is a station where they're gonna walk from station 1 to station 2, and they're pretty simple. I usually give them about 6 minutes. Try not to give them too much time, because then it becomes, anytime there's water, water seems to get a lot of play and activity. So you don't want to give them too much time, but then you also want to make sure they have enough time to actually complete the activity and to discuss what they learned about it.
It looks like a lot of fun.
Yeah.
Definitely a lot of fun.
And still don't have any questions in the Q&A, so back to you, Carol.
Okay. All of the activities shared this evening, plus many, many more, are available on our website for you to download. For our final poll, how comfortable are you using the updated standards with students? A big thank you goes out to our current JSAT teachers for submitting your activities and videos and for providing your students with meaningful hands-on physical science activities. And thank you to our viewers for attending Teacher Night this evening. Good luck with the door prize drawing, and don't forget to apply for JSAT this fall. Jalen, please share our door prize winners.
Thanks again so much to our current JSAT teachers for their activity submissions, our presenters for their amazing videos, and our phenomenal audience of teachers who attended tonight's event. We always look forward to this event, and we hope to see you all again next year at Teacher Night 2023. Before I announce the door prize winners, please make sure that you remain on the webinar to receive the post-event survey. Your responses are essential to our constant desire to improve Teacher Night for you and for your classroom needs. Now, without further ado, here are our winners. Feel free to take a screenshot of each of the following 3 slides to see if you are one of our lucky winners. They will go a little bit fast. I apologize, but feel free to go ahead and do that. Thanks again, everyone, and we hope to see you all at Teacher Night 2023. Have a great night, everyone.